For our next property, let's still lead into it using that same quotient of powers that we used for our zero exponent property. I still have a quotient, x to the third power, divided by x to the fifth power. As we showed several videos ago, I still subtract the exponents. 3 minus 5, but remember, because I'm subtracting a larger number, I get a negative exponent. Well, let's find out what's going on. Think about fundamentally what happens here. X to the third power, my numerator is x times x times x. X to the fifth power, the base, x times itself 5 times. I got 5 x's sitting down there in the denominator. Well, as we talked about with canceling fractions earlier, divide by x, I'm canceling out. This is where it makes more sense because I'm left with, remember the coefficient of my numerator? This is where it's going to be much more essential. Last time where it seemed like, hey, well, why is he putting the 1 in there? Because it was a divide by 1. Well, when it's a 1 in the numerator, it's essential to have because look at what's going on. 1 divided by, well, remember, 3 of them canceled. I had 2 left. X squared. Well, that 2 is that negative 2. What negative exponents mean are, take the reciprocal, throw it down to the denominator, change its position in the fraction. When we think of negative exponents, we want to think of the reciprocal. A reciprocal in fraction, like if I were to give you a fraction of 3 over 4, the reciprocal is, well, you swap the top and the bottom, you change the position, 4 over 3. Even if you had a fraction, 1/2, and you want to take a reciprocal, well, that's going to be 2 over 1. That would end up being a whole number because 2 divided by 1, and it works the same way even if I had a number, 3. If I want the reciprocal of 3, well, it's not even a fraction, you can make it a fraction. Any fraction, any number can be put over 1. 3 divided by 1 is still 3. But now, changing the position, switching the top and bottom, I can make it 1/3. Well, that's what we did back here. Negative exponents, again, we want to think negative numbers. Negative exponents will not be negative numbers. Negative exponents will be reciprocals. Our negative exponent property, if I have a to the negative n power, as bad as I want to say something like negative a, that doesn't work. What I do is I take a reciprocal, 1 over a to the power of n. And let's look at this because this one can even show up in a variety of formats based on whether we have a negative exponent in the denominator, based off whether our base happens to be a fraction. Let's look at a few examples of how this will work.